Hello, welcome back to our channel. Now we are going to discuss about second part of that semiconductor devices. And in this second part, we are giving more preference to logic gates. And before that, I want to share with you few problems related to the semiconductor devices. Look here, based on the depletion layer, we are using this intensity formula. Intensity and potential difference E equals to V by D. E belongs to intensity of electric field, V belongs to potential, and D is the width of the depletion layer. Suppose they are giving V equals to 0.01 volts, then thickness is the 2 millimeters. Then how to find out the intensity? E equals to, it should be like 10 power minus 2 by 2 into 10 power minus 3. After simplification, 10 by 2, 5 Newton per Coulomb. Like that, based on the depletion layer, we can expect this type of questions. Then, based on forward and reverse bias, we are taking one junction diode. You know that this is the P and this is the N. This is giving to the earth, means what is earth connection means 0 potential, and this is giving to 2 volts. So this is which bias? We can say N is giving to the low potential and P is giving to the high potential. We should consider, you can say this is the forward bias. Then second one, you look here, same like that, PN junction diode. This is giving to minus 5 volts and this is giving to minus 10 volts. So which is the high potential and which is the low potential here? See, N is minus 5. Minus 5 is more than minus 10. So you can say this is N is giving to high potential and P is giving to low potential, means this is the reverse bias. And one more example you can take it. This is the PN junction diode. This is giving to the minus 2 volts and this is giving to the earth connection. So this is the 0 volts and this is the minus 2 volts, means what we are taking. So this is giving to high potential. 0 is more than minus 2, means this is also, you can say, the forward bias. Like that, we can able to do these problems based on the forward bias and reverse bias. Then one more problem we are doing based on that full wave and half wave rectifiers. Suppose they are giving forward resistance is the like 3 ohms, then load resistance is the like 300 ohms. Find the efficiency of half wave rectifier, means 0.406. RL is how much? 300 by RL plus RF, we are taking 303. So after simplification we can find out. So you remember that. Suppose they are asking full wave rectifier means 0.812 RL by 0.406 RL by RL plus RF, like that you can take it. So in the case of half wave and full wave, you should remember these two formulas, then easily you can able to find out the efficiency. Then based on the transistors, they are giving that find the current amplification factor. See, if beta equals to 50, find the current amplification factor in the case of common base. Common base means it is represented by alpha. Alpha, what is the formula? Beta by 1 plus beta. So 50 by 51. You are getting 0.9 like that. So like that we should find out the alpha also. Suppose they are giving alpha equals to 0.1. Find the beta. This is the current amplification factor at common emitter. This is the common emitter and this is the common base. So beta equals to what we are taking? Alpha by 1 minus alpha. 0.1 by 1 minus 0.1 is the 1 by 0.9. It should be right 10 by 9 like this. So 1 point something you are getting. So these are the relations between alpha and beta. Not only this one, suppose they are giving, you know that there are 3 layers in the case of transistors: emitter, base and collector. Suppose base current is the 2 milliamperes and collector current is the like 20 milliamperes. Find the emitter current, means we can take it IE equals to IB plus IC. So the answer is how much? 22 milliamperes. Like that we can find out the with the help of this formula, based on the given data, you can able to find out collector current, base current, or emitter current also we can able to find out. Not only this one, power gain. Power gain. How to find out the power gain? We can take it that is the V square R. Voltage gain square by that one based on the resistance you can able to find out. So once you revise that formulas, you can able to do semiconductors problems. Then our second part of that semiconductors are the logic gates. Logic gates. There are three basic logic gates are there. One is the OR gate, another one is the AND gate, and last one is the NOT gate. OR gate is responsible for, this is belongs to addition, AND gate belongs to multiplication, NOT gate it is having only one input and one output. Look here, first we are going to discuss about the OR gate. We are using the capital letters here. These are the logic gates. Logically we should do the operations, and we are not using 1, 2, 3 like that. Simply we can use the low and high. We are using two things only. Low is represented by 0 and high is represented by 1. Otherwise simply we can use as a terms low and high, that one. So in this case the symbol is like this. The symbol for OR gate is like this. It has two inputs and one output, A, B, C. Then when you are coming to the truth table, see A, B, C. 0, 0 are the inputs. 0 plus 0, how much? 0. 0, 1. 0 plus 1 is the 1. 1 plus 0, 1. 1 plus 1, don't write the 2, 1 only. So high plus high is the 1. Any one input is the high, output is also high. So this is belongs to the OR gate. The next gate is the AND gate. AND gate belongs to multiplication. See, the symbol for AND gate is like this. It has two inputs and one output, A, B, C. Truth table you look here. 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So any one input is low, output is also low. This is belongs to the AND gate. Then one more gate is the NOT gate. What is the NOT gate? It has only one input and one output. It has only one input and one output. The symbol is like this. If it is A, output is what? A bar. See, truth table, A bar. If A is the 0, A bar is 0, bar is the 1, and 1 is bar equals to 0. So these three are called the basic logic gates. Logically we can do the operations with the help of the binary system. Only 0 and 1 we are using. 1 belongs to high and 0 belongs to low. Then two more logic gates are there. Those two are called the universal logic gates. Why those two are called the universal logic gates? With the help of that we can construct any logic gate, AND gate, OR gate, NOR gate, NAND gate, any logic gate we should consider. That's why those two are called the universal logic gates. Then come to here. See, first one is the NOR gate. First of all, what is the meaning for NOR gate? R plus NOT. R plus NOT is called the NOR gate. Generally symbol is like this. Symbol is like this. It has two inputs and one output. See, look here how the truth table. Before that you have to remember this formula is A plus B whole bar equals to A bar dot B bar. Like that, A bar into B bar. See, 0 plus 0 how much? 0 only, but 0 bar equals to 1. 1 plus 0, 1. 1 bar equals to 0. Then 0 plus 1, 1. 1 bar equals to 0. Then 1 plus 1, 1. 1 bar equals to 0. Just opposite of this OR gate you are getting. And it should be right like this also. It is like length, we can cut like this. Here one drop you can take it. This is also, we can say that NOR gate. This is about the NOR gate. Then next one is the NAND gate. What is the NAND gate? Same you can say AND plus NOT. and plus not is called the Nand gate. Here also you can take the symbol directly, like this also you can take it. Later you can simplify this one, but output you see A B bar equals to A bar plus B bar, like that you can take it. It should be simplified and you can draw like this also. This is also belongs to Nand gate. It has two inputs and one output. See, look here, A, B, C. 0 into 0, 0, but 0 bar equals to 1. 1 into 0, 0. 0 bar equals to 1. 0 into 1, 0. 0 bar equals to 1. 1 into 1, 1. 1 bar equals to 0. Just opposite of this AND gate you are getting. Why these are the universal logic gates? We are going through few problems. Look here. See, this is what gate? This is the NOR gate. NOR gate, NOR gate, NOR gate. The question is, it is representing which gate? It is representing which gate? So we have to find out the truth table is matched to which one. So suppose I am taking this A and B. Suppose I am taking A equals to 1, A equals to 1. See, A equals to 1 and B equals to 1. See, 1 here not is there. 1 bar becomes to how much? 1 bar becomes to 0. Here also 1 bar becomes to 0. So 0 plus 0, 0. But here 0 bar equals to how much? 1. So once again 1 bar equals to how much? 0. So when we are giving the inputs 1 and 1, 1 and 1, but output is how much? 0. When we are going through the cross checking of that one, OR gate, you know that 1 plus 1, 1. AND gate also 1 into 1, 1 only. But which gate you are getting this 1 into? Here we are taking 1 into 1. What we are getting? 0. So you can say this is belongs to which gate? This is the NAND gate. You can say this is the NAND gate. Like that here one input is there. 0, 1, 0, 1. How can you show like a wave here? 0, like sleeping line. See, high, this is the low. High belongs to 1. Once again low, this is the high. Like that we can draw and we can give the answer. Then this question you look here. See, they have given two options which is right, but the question is they have given the symbol for this one, but find the output must be 1. Output must be 1. So which is suitable for that? For this output equals to 1, you should cross check here. We are taking A equals to 0 and B equals to 1. See, A equals to 0, B equals to how much? 1. 0 plus 1 how much? 1 you are getting. But C value how much they have given? C equals to 0. C equals to 0. So here 1, 0. This is which gate? AND gate. 1 into 0 how much? 0. So output is how much? 0. So this is the wrong option. Like that you should cross this one. A is 1, B is 0. 1 plus 0, 1 only. But C equals to how much? 1. 1 into 1 how much? 1. So which option is right? Second option is right. So this is the belongs to the logic gates, and there are two parts for semiconductor devices. This is the second part, and it is also one of the big chapter, and theoretical questions also we are expecting, and better you should follow and practice more problems from your materials also. Thank you everyone. Please subscribe my channel and share my channel to your friends also.